Good morning friends. Today I am going to explain the quantum physics most important problems, and these are the problems which are very important for the NET exam, GATE exam, SET exam, Jest exam and IIT JAM. Here the problem is, if the oscillator is in its normal state, then the probability of finding the particle outside the classical limits is approximately equal to 16%, 24%, 48% or 84%. Solution for this problem is, in normal state of oscillator, probability of finding the particle in classical region is can be given as, so we know this one, this equation, that is in quantum mechanics, the omega is equal to minus a2 plus a sin naught star sin naught dx. So we know that sin naught value is alpha by root pi to the power of half e to the power of minus alpha square x square by 2. Now first of all we are going to find out the limits value, that is, for finding the value of a, we have to consider the energy of oscillator in ground state is given by. So we know that ground state energy E naught will be equal to 1 by 2 h bar omega square. Let us take this is equation number 1. Now according to the classical mechanics, total energy of the particle is given by E naught is equal to 1 by 2 m omega square a square. So where a is the amplitude of the particle. Here these two equations are related to energy only, so that's why we are going to equate these equations, that is equation number 2 and equation number 2, equation number 1 and equation number 2. So when you equate these two equations, we will get 1 by 2 m omega square a square is equal to 1 by 2 h bar omega. So a square will be equal to h bar omega m omega square, and 2 get cancelled, then a square will be equal to h bar by omega m omega, then a is equal to under root of h bar by m omega. So now we got the value for a, minus a to plus a values. So that can be replaced, these constants are replaced by one single constant, that is 1 by alpha. So here in this equation we need in the form of alpha only, these are alpha, so that's why we have to make this a is equal to under root of h bar by omega is equal to 1 by alpha. Now substituting the value of a in equation number, substituting the value of a in equation number 8. So this is the equation number 1, that is sin naught star sin naught. Here substituting, and at the same time when you substitute this value of a, then minus 1 by alpha to plus 1 by alpha, alpha by root by e to the power of alpha square x square into dx. And for our convenience we are substituting alpha x is as q and alpha dx is dq in equation number b. So then it will be minus 1 to plus 1, 1 by root pi e to the power of minus q square and dq. Here 2, so minus 1 to plus 1, the limits becomes 0 to 1, and 2 by root pi. Here this equation can be written as like this, e to the power of minus q square into dq. Next e to the power of minus q square expansion we can write here 2 by root by 0 to 1, 1 minus q square plus q to the power of 4 2 factorial minus q by to the power of 6 3 factorial plus q to the power of 8 4 factorial and so on. So this is the expansion of e to the power of minus q square into dq. So now when you integrate to this equation, that is 0 to 1 1 into dq can be written as q, or 0 to 1 q square into dq is can be written as q cube by 3 plus. So similarly we can write q5 by 10 minus q7 by 42 and so on, and limits are 0 to 1. So when you substitute the limits in this equation, then it becomes 2 by root pi 1 minus 1 by 3 plus 1 by 10 and minus 1 by 42 and so on. So there if you simplify this equation, it becomes 0.84, and that is equal to 84%. So now our aim is we have to calculate the particle outside the classical limits. So that's why the probability of finding the particle outside the classical limits in the normal state of the harmonic oscillator is can be given as omega dash is equal to 1 minus omega. So omega we got 0.84. So 1 minus 0.84 here. this becomes 0.16. So the value of this one is 16%. It means the option A is correct. This is, if the oscillator is in its normal state, then the probability of finding the particle outside the classical limit is approximately equal to the 16%. Thank you. For more videos, subscribe my channel Physics.